And next concept is tree. So tree follows this is the symbolic representation of the tree. So normally we have to, this is normal natural view of the tree. So in this tree, we want three basic things. One is a root. So without root, we can't, the tree can't able to withstand. So the root is main thing for growing the tree. So next one is leaves, and these are all represented as the branches. So this is the natural view of the tree. So this is compared with our concept. So here the main thing is root, and another one is branches. These are all leaves. So each and every part is known as a node. So now we are going to compare this concept with our data structure concept. So here tree is the finite non-empty set of elements. So these are all the elements. So this is non-empty set. We have to fill some other words in each and every node. So in nature view of tree, we need three concepts. One is leaves, root, and then branches. The same thing we have to follow here. So this one is represented as the root. So these are all the branches, and these are all known as leaves. Leaves means the node without having any child is known as leaf. Okay, so here these are all known as leaves. So this is the basic representation of the tree. So these are all the tree terminology we have to use. First one is root. So this one is root. So this is basic structure for the following tree. So sibling means a node share the same parent. So B, C, D, these are all the child for node A. So sibling for A is, so sibling for B is C, and C is D, and C is D and B, and for D is C and B. Next one is internal node. A node with at least one child is known as internal node. A node, for example, B. So here a node with at least one child. So A having 3 child. So A is the internal node, and B having 2 child. So B is the internal node, and C is having 2 child. So C is the internal node. But D doesn't have any child. So D is not an internal node. But here F having 3 child. So F is the internal node. So internal node means a node with at least one child. And external node means a node without children is known as external node. Here E doesn't have any children, and I doesn't have any children. J, K, G, H, D. So these nodes doesn't have any child. So this is the example of these are the example of external node. So here ancestor of a node. So ancestor of a node represents A, that is a root of the node, parent or grandparent, etc. So these are known as the ancestor of the node. And descendant of the node. So this is the child and grandchild. So here B, C, D. So these are all known as descendant of the node. So height of the tree means maximum depth. So here it represents 1, 2, 3. So maximum depth of the tree is 3. So degree of the node means the number of children. So for A the degree is 3. For B the degree is 2. That is the number of children. So A having 3 children. So A the degree of node is node A is 3. So B having 2 children, so the degree of a node B is 2. Next one is subtree. So tree consisting of a node and this descendants is known as subtree. That is A having the subtree as B, C and D. So a tree consisting of a node and this descendant is known as subtree. Next one is binary tree. A binary tree means a tree with at most 2 children is known as binary tree. So it must be binary means 2. So here a node with at most 2 children is the binary tree. So that is 2 children should be there for each and every node. See, A having 2 children, B having 2 children, and E having 2 children, and C having 2 children. So binary means 2. A node with 2 children is known as binary tree. So in binary tree node with no successor are called as terminal node. That is here D, H, I, F, G. These are all the node which doesn't have any children. So these nodes are known as terminal node or leaf node. So a terminal node is also known as leaf node. So up to this, the basic concept of data structure is over. Thank you.